Way 41 deals with ionization energy. And ionization energy is the amount of energy it takes to remove a single electron from an atom. Recall that when atoms lose electrons, they become an ion. They become a positively charged ion. So if it takes a lot of energy to remove an electron, it means that it's hard to remove an electron. If it takes very little energy to remove that electron, it means it's very easy to ionize that atom. Typically, you can use table S to find out the first ionization energies for any elements. So you can use this to establish trends among the periodic table. In general, ionization energy increases as you go from bottom to top and in a group, and it increases as you go from left to right in a period. So atoms that have the highest ionization energy are more toward the top right, and atoms with the least ionization energy are more toward the bottom left. So let's try some problems that deal with ionization energy. Which trend is observed as the first four elements in group 17 on the periodic table are considered in order of increasing atomic number? The only trend that makes sense is first ionization energy decreases. If you look at group 17 and look at their ionization energy values, you'll find that the values decrease down a group. And that's primarily because the electrons are further away from the center of the atom, so they experience less pull. So the more energy shells an atom has, the easier it is to remove those outer valence electrons. Many scientists made observations of the elements that led to the modern periodic table. In 1829, Dobereiner found groups of three elements that have similar chemical properties and called each of these groups a triad. Dobereiner noticed a relationship between the atomic masses of the elements in each triad. Triad 1, shown in the table below, consists of sulfur, selenium, and tellurium. The middle element, selenium, has an atomic mass that is close to the sum of the atomic masses of sulfur and tellurium divided by 2. For example, 32 AMU plus 128 AMU divided by 2 equals 80, which is close to the 79 AMU value in the table. The other triads shown in the table below demonstrate the same mathematical relationship. So you have three different triads, and notice if you look at these triads, they all belong to the same group. It says state the trend in the first ionization energy as the elements in triad 3 are considered in order of increasing atomic number. So what's happening to the ionization energy for triad 3 as we look at the atomic numbers increasing? Notice that chlorine, bromine, and iodine are all part of the same group, group 17, and we know that ionization energy generally decreases down a group. So you could simply just say that the first ionization energy decreases, and that would be sufficient. In the ground state, an atom of each of the elements in group 2 has a different If you look on your periodic table, group 2 all has the same oxidation state, positive 2, that top right corner of the periodic table. They also have 2 valence electrons, the last digit in their electron configuration. And the number of electrons in their first shell is always 2. That's the first digit indicated in their electron configuration. The only thing that makes the most sense is first ionization energy, which is the correct answer. As the first 5 elements in group 15 are considered in order of increasing atomic number, first ionization energy if you remember, the number of shells increase as you go down a group because the size of the atom increases. So the electron's further away. The further away, the easier it is to remove an electron. So we would experience a decrease in first ionization energy. Which general trend in first ionization energy and electronegativity values are demonstrated by group 15 elements as they are considered in order from top to bottom? Remember, groups are the vertical columns on the periodic table. And this is asking you to apply your knowledge of ionization energy and electronegativity. You should note that both ionization energy and electronegativity decrease down a group, so the correct answer is 1. Which statement describes the general trends in electronegativity and first ionization energy as the elements in period 3 are considered in order from Na to Cl? You should note that both electronegativity and first ionization energy, I'm sorry, that's incorrect. It should be 3. They both increase. So the correct answer is 3, not 4. Apologies. Which atom in the ground state requires the least amount of energy to remove its valence electron? So, amount of energy needed to remove its valence electron refers to the first ionization energy. We're looking for which one has the least. Okay, you'll note that the answer is 3. If you look up the ionization energies for all these values, rubidium actually has the lowest ionization energy, and it's actually the lowest in the group. It's the farthest. It's down at the bottom left corner of the periodic table, and therefore would have the lowest ionization energy. Alternatively, you can use table S to look up the values and calculate and look up the ionization energy values and find out which one is indeed the smallest. Okay, so when it comes to ionization energy, remember you have table S to rely on. Alternatively, know that elements in the top right corner of the periodic table are going to have the highest ionization energies, and elements in the bottom left-hand corner are going to have the lowest. So ionization energy decreases as we go down a group and increases as we go across a period. Thank you.